A very warm good afternoon to everyone. Today we will solve section 3 of internal 1 paper. In earlier videos, we had covered section A in one video, section B in the second video. Now this is the third video of section C of first internal. Question number 1 read as discuss accuracy, completeness, consistency issue, missing timestamp, contradictory narratives, mistyped sections, propose two more quality dimensions relevant to legal analytics, timeliness, verifiability, provenance, solution. Accuracy means data may be incorrect or wrongly entered. Example, mistyped names, wrong timestamp. Completeness means some required information is missing. Example, missing timestamp, missing section in narrative. Consistency, information conflicts with itself. Example, two different dates or contradictory statement for the same event. Two more quality dimension. Timeliness, data must be up to date and recorded on time. Verifiability, provenance, the source of data should be traceable and trustworthy. Now moving to question number second, which read as for handling missing values in extracted features, discuss approaches, ignore tuples, manual completion, constant field, mean, median, mode imputation, class specific imputation, most probable value model based. Answer, ignore tuples. It means remove records that have missing values. Just remove that records. Manual completion. It says that human examines the FIR complaint and field missing information. Constant field means replace missing values with a fixed value. Example, either with 0 or with the unknown string. Mean, median, mode imputation means replace missing values with either an average or a middle value, that is median, or the most frequent value, that is mode. Class specific imputation. It says that just fill the missing value using statistics of its category. Example, same offense type, most probable value model based. Use ML models to predict the missing value using other attributes. Now the third question is smoothing extracted scores. Use the evidence strength list from A2. Smooth using bin means with bin depth 3 steps. So for a smooth using bin means bin depth equal to 3 steps includes number 1 sort the scores, number 2 divide them into bins of size 3, number 3 compute mean of each bin, number 4 replace each value in the bin with dead median. For example, scores is given as 2, 3, 4, 7, 8, 9. So beans here is 2, 3, 4 means equal to 3, 7, 8, 9 for 7, 8, 9 mean equal to 8. So the smooth output will be 3, 3, 3, 8, 8, 8. B read as solving the B section suggest ways to detect outliers, rare, very high impact with low evidence. Ways to detect outliers. Values far away from the average, too high or too low. Use Z-score, value greater than 3 standard deviation. Use IQR method, values beyond Q1 minus 1.5 into IQR or Q3 plus 1.5 into IQR. Visual checks, box plots or scatter plots. C is discuss other smoothing methods, mean, medians, lows, moving averages, robust estimator. So bean medians means replace each bean with its median, more robust to outliers. Moving averages means smooth using average of sliding window. Lowest means local regression that feeds small curves to smooth trends. Fourth is robust estimators. Use trimmed means or weighted averages to reduce noise. Now moving to question number 4. Discuss schema integration, handling redundant entries, duplicates across EFIR and physical logs, and resolving value conflicts. Example, differing monetary laws or section labels. Answer, schema integration. Combine data from different sources, EFIR, physical FIR, police logs into one unified structure. Handling redundant entries. Remove duplicate complaints that appear in multiple sources. Resolving value conflicts. Choose the most reliable source or use majority vote, latent lattice value or ask officer manual check when differences exist. Example, different monetary loss values. Now moving to question number 5. Explain normalization methods for feature scaling. Part A read as mean max normalization. In it, what we do, we scales value into a fixed range, usually 0 to 1. The formula for it is x is equal to x minus mean upon my max minus mean. B, z score normalization. In it, we uses mean and standard deviation. So x is equal to x minus standard deviation upon my sigma. It gives data with mean 0 and standard deviation 1. C, Z score using mean absolute deviation. So here Z score using mean absolute deviation. Same idea as Z score but uses MAD instead of standard deviation. More robust to outliers. The formula for it is S is equal to X minus U upon my MAD. D, decimal scaling. Decimal scaling shift decimal point until value becomes between -1 and 1. X is equal to X upon my 10 to the power J. Now moving to question number 6. Meaning case severity scores 5, 10, 11, 13, 15, 35, 50, 55, 72, 92, 204, 215 partition into A. A equal frequency beans. We have 12 values. So for 3 beans, 4 values per bean. Each bean gets equal number of values. Sorted list will be 5, 10, 11, 13, 15, 35, 50, 55, 72, 92, 204, 250. Beans here. Bean 1, 5 to 13, bean 2, 15 to 55, bean 3, 72 to 250. B part equal with beans. Find range 215 minus 5 which is 10, which is 210. If 3 beans, so the width will be 210 divided by 3 which is equal to 70. So the beans here, beans 1 5 to 75, the value is given. Bean 2 75 to 145, that is 92. Bean 3 145 to 215 which is 204 to 215. Now the moving to C part, clustering based beans example K means. Clustering based means values necessary cluster as cluster 1 low, cluster 2 medium, cluster 3 high. Implication for section mapping threshold short. Beans help to decide low, medium and high severity categories. Threshold change depending on binning methods. Equal frequency means balance groups. Equal width means wide, low severity range. Clustering means capture natural separation in real complaints. Now moving to the question number 7. Feature selection for section mapping. Summarize with the flowchart the technique for choosing attributes used by the DSS. A. Forward selection. Forward selection means start with no features, add features one by one that improve accuracy the most. Backward elimination B part. Start with all features, remove the least useful feature step by step. C. Hybrid method. Hybrid method is a mix of both. Add good features and remove weak ones. Now the flowchart will be forward, select best features, backward, remove worst features, hybrid, add plus remove best combination of both, and then stop. Hope you enjoy the video. We had clearly explained the solution of each questions in step by step manner. Also, if you have any kind of doubts or queries regarding any question, you can comment down in the comment section, write your query. We will soon try to reach you out and answer your questions. Hope you enjoy the video. Have a good day.